Welcome to the deep dive. Today, we're diving into multimodal mathematics,
Oh, wow.
where AI is learning to solve problems, not just with equations, but also with diagrams and visual information.
Yeah.
Like, imagine teaching a computer to see a geometry problem and actually reason through the proof.
Yeah.
You sent us this research paper on a system called URSA,
hmm
and it's really quite mind-blowing.
It's really exciting. What's really exciting about this is that it uses what's called chain of thought reasoning, right? So instead of just spitting out an answer,
Right.
it breaks the problem down into steps,
Okay.
like a human would.
So it's showing its work
Yeah.
instead of just the final answer.
Exactly. Yeah.
But how does that actually work with images involved?
Right. Well, that's the challenge that URSA is tackling.
Yeah.
Um, Existing models haven't been great at this kind of complex reasoning,
Uh-huh.
especially when it comes to things like geometry.
So how did they design URSA to be different?
Well, they trained it on a huge data set of over 1 million multimodal math problems. It's
Yeah.
called MMathCoT1M.
Okay.
And it's not just about getting the right answer.
Yeah.
It's the data set includes the entire reasoning process.
That's interesting. So it's learning how to think,
Yeah,
not just what to think.
exactly. Yeah.
Now, the paper mentions a 3-stage training process.
Uh-huh.
What's happening in each of those stages?
Okay. So the first stage is all about aligning vision and language, right? So URSA learns to connect the visual elements in a diagram with the words in the problem.
Okay.
So think of it as learning the vocabulary of visual math.
That makes sense. So once it understands the language,
Yeah.
what happens next?
Stage 2 is where the real magic happens.
Okay.
This is where URSA learns to generate those step-by-step reasoning chains,
Yeah.
mimicking how a human mathematician would approach the problem. It's trained on data sets that, provide not just the answer,
Yeah.
but the logic behind it.
I'm starting to understand why you were so excited about this.
Yeah.
And stage 3.
This is where it gets really interesting.
Yeah.
In this stage, URSA is actually trained on problems
Okay.
with deliberate errors in the reasoning.
Wait, they're teaching it to make mistakes?
Yeah.
I wouldn't think that would be helpful.
It's kind of counterintuitive, but it works. By learning to identify and correct these intentional errors,
Mhm.
URSA becomes much more accurate and reliable.
Oh,
It's kind of like
cool.
a student, right?
Yeah.
Learning from their mistakes to avoid them in the future.
That's a brilliant approach. So they're basically building a more resilient system by exposing it to flawed reasoning.
Exactly, yeah.
What kind of results are they seeing after this 3-stage training process?
Well, the results are pretty impressive. I mean, it's outperforming other models on standard benchmarks,
Okay.
especially when it comes to geometry and algebra. And what's really cool is that it's actually capable of recognizing when it makes mistakes and learning from them.
Wow, it's like it has a built-in error checking mechanism. But how does it compare to other models
Yeah.
when you actually throw real problems at it?
It's consistently outperforming even models that are designed specifically for math.
Right.
The paper highlights its success on benchmarks like MathVista and MathVerse, which are really designed to test a wide range of mathematical skills.
Can you give me an example of where URSA really shines
Sure.
compared to the others?
Absolutely. So one example is in geometry problems on the MathVista benchmark, right?
Yeah.
So there's this problem involving a parallelogram,
Okay.
and you have to find the length of a certain segment.
Yeah.
And it requires understanding both the geometric concepts and how they apply to the diagram.
Right.
And URSA, nailed it.
Okay.
It breaks the problem down into these logical steps, just like a skilled geometer.
So it's not just finding the answer,
Yeah.
it's demonstrating a real understanding
Exactly.
of the geometry involved.
Yeah.
But what about other areas of math? Is it limited to geometry?
Not at all. Okay. It performs well across different areas, including algebra
Uh-huh.
and even functions. And what's remarkable is it consistently outperforms
Yeah.
other models. It's setting a new standard for AI in mathematics.
This is incredible. It sounds like URSA is not just solving problems.
Yeah.
It's actually understanding the underlying mathematical concepts.
Yeah.
But I'm curious, the paper also emphasizes the importance of understanding the reasoning process behind the solutions. How does URSA make its solutions more transparent and understandable,
Right.
even for someone who's not a math whiz?
Well, that's one of the key advantages of chain of thought reasoning, right?
Yeah, yeah.
Instead of just giving it, a final answer,
Yeah.
it explains how it got there, step by step.
So you can see its thought process,
Yeah.
not just the result.
Exactly, yeah.
That makes a lot of sense, especially for something as complex as math.
Uh-huh.
You need to know it's not just making lucky guesses.
Right, exactly. It's about building trust and transparency, right?
Yeah.
Especially when we're talking about AI tackling complex problems.
Yeah.
And this transparency allows for better error analysis as well.
Okay.
So, if URSA makes a mistake,
Right.
you can examine its reasoning, see where it went wrong,
Uh-huh.
and that can help identify any flaws in its training or algorithms.
That's such a valuable tool for researchers.
Yeah.
So it's not just about celebrating the successes, it's
Right.
about learning from the mistakes
Yeah.
to make the system even better. But beyond just solving problems, the paper also mentions another fascinating capability of URSA. It can act as a verifier
Uh-huh.
to assess the reasoning of other AI models.
Right.
Tell me more about this verifier role and why it's so significant.
Okay, well, imagine a scenario where you have a bunch of AI models,
Okay.
kind of like students in a class.
Yeah.
And they're all trying to solve the same math problem.
Uh-huh.
Some might get it right.
Right.
Some might struggle. Now, picture URSA as the teacher, going through each, student's work.
Okay.
Not just checking the answer, but evaluating the logic and reasoning behind it.
So it's not just grading the final answer.
Yeah.
It's looking at the whole thought process. Why is that so important?
Well, this feedback is crucial because it allows us to see where other AI models might be going wrong.
Right.
Highlighting their strengths and weaknesses.
Yeah.
It's like having a personalized learning plan
Oh, okay.
for each AI student
Uh-huh.
to help them improve.
That's amazing.
Yeah.
It sounds like a game changer for evaluating and improving AI systems. It's almost like a quality control expert
Yeah.
for AI reasoning.
Yeah, exactly.
But as impressive as all this is, I have to ask, what are some of URSA's limitations? Is it
Oh.
perfect?
Well, no, no AI system is perfect.
Yeah.
And URSA is still a work in progress.
Okay.
One limitation is that its training data,
Yeah.
while vast,
Uh-huh.
is still finite. Right. There might be types of math problems
Yeah.
or concepts that it hasn't encountered yet.
So there are still areas where it might struggle.
Yeah.
What else?
Another limitation is that URSA's reasoning is still largely confined to the abstract world of mathematics.
Uh-huh.
So it can manipulate symbols and equations brilliantly,
Yeah.
but it doesn't have a real grasp of how those concepts apply to, real-world situations.
So it can solve a geometry problem on paper,
Yeah.
but might not know how to apply that knowledge to building a bridge.
Exactly. Yeah. Bridging that gap between, symbolic reasoning
Right.
and real-world understanding is a huge challenge for AI research.
Yeah.
And it's something that, researchers are actively working on.
That makes sense. It's exciting to see what they come up with next. Now, before we move on, I want to go back to the concept of test time scaling that you mentioned earlier.
Uh-huh.
Can you explain that again?
Sure.
And how it's used with URSA?
Okay. So in a typical AI evaluation, right?
Yeah.
You train a model
Right.
and then you test it on a separate data set
Mm-hmm.
and you just run it once
Yeah.
on each problem and you measure its performance.
Okay.
But test time scaling takes a different approach.
Yeah.
You actually run the model multiple times
Okay.
on the same problem.
On the same problem.
Yeah, but each time
Yeah.
with slight variations in the inputs.
Okay.
And then you choose the best solution
Oh,
out of those attempts.
so it's like giving URSA multiple tries at the same problem.
Yeah,
But with a slight twist each time.
exactly.
What's the benefit of that?
Well, the idea is that by exploring different, variations and perspectives,
Huh?
the AI has a better chance of finding a really robust and accurate solution.
Oh, okay.
It's like a student trying different strategies to solve a tricky problem
Yeah.
until they hit on the one that works best.
I like that analogy.
Yeah.
It makes the concept much clearer. And how does URSA perform
Yeah.
with this test time scaling?
The results are very promising. It significantly improves URSA's performance
Okay.
on those benchmark data sets.
Oh, wow.
It's like, giving it a boost in reasoning power
Yeah,
by allowing it to explore different approaches.
that's incredible. It seems like test time scaling could be a key tool for maximizing AI performance.
Yeah.
But now I want to shift gears a bit and
Okay.
talk about something that's been on my mind throughout this whole discussion.
I'm all ears. What is it?
We've talked about URSA's ability to solve problems,
Yeah.
reason logically,
Uh-huh.
even verify other AI models.
Yeah.
But what does all this mean for the bigger picture?
Right.
What does this research tell us about the future of AI and how it relates to human intelligence?
That is the big question, isn't it?
Are we on the verge of creating AI that can rival human intelligence?
Well, I think it's important to be cautious about making such sweeping statements, right?
Yeah.
I mean, AI has made amazing strides, but we're still far from creating machines that can match the full range and flexibility of human intelligence.
So URSA, as impressive as it is, it's still more of a specialized tool
Yeah.
rather than a general intelligence.
Yes, exactly. Yeah.
Okay.
I mean, URSA is a master of multimodal mathematics, but it can't write a poem
Right.
or compose a symphony or design a scientific experiment.
Right.
I mean, those require different kinds of intelligence, different ways of thinking and reasoning.
So it might be able to solve a geometry problem better than any human.
Uh-huh.
But it's not going to replace mathematicians anytime soon.
Not at all. In
Yeah.
fact, I believe that AI systems like URSA will actually become increasingly valuable collaborators for humans,
Okay.
helping us to tackle complex problems in new and innovative ways. It's about augmenting our abilities,
Right.
not replacing them.
So it's more about AI and human intelligence working together
Yeah,
rather than competing.
exactly. Yeah.
I like that perspective.
Yeah.
What do you think the future holds for this kind of collaborative intelligence?
Oh, the possibilities are really exciting. I mean,
Yeah.
imagine AI helping us, make groundbreaking scientific discoveries or develop sustainable energy solutions or address some of humanity's biggest challenges.
That's a very hopeful and inspiring vision of the future.
Yeah.
It seems like this research is not just about building smarter machines.
Yeah.
It's about expanding our understanding of what intelligence can be
Right.
and how we can harness its power for good.
Absolutely. And that's one of the most fascinating aspects of AI research.
Yeah.
It pushes us to rethink our own assumptions about intelligence
Yeah.
and what's possible.
This has been an incredible journey into the world of multimodal mathematics
It really has.
and the impressive capabilities of URSA.
Yeah.
It's a glimpse into a future where AI is not just crunching numbers,
Uh-huh.
but truly understanding the language of mathematics.
Exactly, yeah.
And for our listener, if you're as intrigued by this as we are,
Yeah.
we encourage you to check out the full research paper.
Yeah.
It's packed with even more fascinating details
Definitely.
about URSA and the world of multimodal mathematics.
Absolutely.
And if you're feeling ambitious,
Yeah.
you could even explore some of these techniques yourself.
Right.
There are open source tools and data sets available online to help you get started
Yeah.
with multimodal AI and chain of thought reasoning.
Absolutely.
You never know, you might discover the next AI breakthrough.
That's a great idea. Who knows what incredible discoveries await us
Yeah.
as we continue to push the boundaries of what's possible with AI.
That's the beauty of research, isn't it?
It is, yeah.
There's always more to explore.
Yeah,
More to learn.
absolutely.
But before we get too carried away with future possibilities, I want to bring it back to the present and dig a little deeper into the specifics of URSA's performance.
Yeah.
The paper mentions impressive results on benchmark datasets like MathVista,
Mm-hmm.
MathVerse, Dynamath, and WeMath.
Let's dive into those details.
Perfect. We'll be back in just a moment to unpack those benchmarks and what they tell us about URSA's capabilities.
Sounds good. So we left off talking about those benchmark data sets.
Right, like a level playing field to see who's really excelling.
Exactly.
What can you tell us about URSA's performance on these benchmarks?
Well, it's consistently outperforming other state-of-the-art models, particularly in areas like geometry and algebra.
Okay.
Let's take MathVista as an example.
Okay.
This benchmark is designed to specifically test multimodal reasoning,
Uh-huh.
and URSA achieves state-of-the-art performance, even
Yeah.
surpassing specialized math models.
So it's not just good,
Yeah,
it's setting a new standard.
it is. Yeah,
Can you give us a specific example of where it really shines on MathVista?
absolutely.
Yeah.
So one problem involves a parallelogram
Okay.
with specific measurements and an angle bisector.
Great.
The task is to find the length of a particular segment within the parallelogram.
Uh-huh.
Other models really struggled with this, either failing to provide a solution
Right.
or producing flawed reasoning.
Yeah.
URSA, on the other hand, navigates the problem with a really clear and logical strategy,
Okay.
demonstrating, a deeper understanding of the geometric concepts at play.
It sounds like it's not just memorizing formulas.
Yeah.
It's actually thinking like a geometer.
Exactly.
What about other benchmarks? How does it perform on those?
So it excels on MathVerse as well,
Okay.
another challenging benchmark that tests mathematical skills
Right.
across various scenarios.
Yeah.
And it consistently scores high in tasks involving, plane geometry, solid geometry, and even functions,
Okay.
showing its versatility.
It's amazing to see an AI model with such a broad range of capabilities in math.
It is, yeah.
But beyond just getting the right answers, the paper also emphasizes the importance of transparency
Right.
in the reasoning process.
Yeah.
How does URSA make its solutions more understandable,
Uh-huh.
even for someone who might not be a math expert?
That's where chain of thought reasoning really shines.
Right.
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 It doesn't just provide the answer.
Yeah.
It lays out its entire thought process,
Okay.
step by step,
Yeah.
just as a human mathematician would.
Right.
And this makes it much easier for anyone to understand how it arrived at the solution
Okay.
and to verify that the reasoning is sound.
So you can follow its logic,
Yeah.
making it more trustworthy
Exactly.
and easier to analyze if there are errors.
Yeah.
That's a big deal, especially as AI systems become more integrated into our lives.
Yeah.
We need to understand how they're making decisions.
Precisely. Yeah.
Yeah.
Transparency builds trust,
Uh-huh.
and it allows for better collaboration between humans and AI.
Yeah.
It also makes it easier to identify and correct, biases or errors
Okay.
in the AI's reasoning.
That makes a lot of sense. We touched on the concept of URSA acting as a verifier for other AI models. Can you explain in more detail how that works
Sure.
and why it's such a groundbreaking development?
Okay, so imagine URSA as a teacher
Okay.
grading the work of other AI students who are all trying to solve the same math problem.
Okay.
It goes beyond just checking for the right answer.
Right.
It carefully scrutinizes the reasoning process
Yeah.
of each model,
Okay.
identifying, flaws, inconsistencies, and areas for improvement.
So it's like a quality control expert for AI,
Exactly.
making sure everyone is following the rules of logic and reasoning.
Exactly.
Yeah.
And this verifier role has huge potential.
Yeah.
It can help identify biases in other AI models,
Uh-huh.
improve the overall reliability of AI systems,
Right.
and even foster a more collaborative approach to AI development where, different models can learn from each other's strengths and weaknesses.
It's like a peer review process
Yeah.
for AI.
Leading to more robust and trustworthy systems.
Yeah.
But while all this sounds amazing,
Yeah.
I'm sure there are still challenges and limitations.
Of course. Of course.
What are some of the areas where URSA could improve? Or where researchers are still facing hurdles?
Well, one challenge is the sheer complexity of mathematics itself.
Right.
I mean, while the MMath CoQ1M dataset that URSA trained on is massive,
Yeah.
it still represents only a fraction of all possible math problems and concepts.
Oh.
So as we, move towards more advanced mathematical reasoning,
Yeah.
we'll need even larger and more diverse data sets to train future AI systems.
It makes sense.
Yeah.
There's always more to learn.
Yeah.
Even for an AI.
Absolutely.
Are there any other challenges?
Another hurdle is connecting symbolic reasoning to real-world understanding.
Okay.
So URSA can masterfully manipulate, symbols and equations,
Yeah.
but it lacks the real-world experience and context that humans have.
And this makes it difficult for it to apply its knowledge to practical problems.
Right.
Like engineering or physics or even everyday tasks that involve, spatial reasoning.
It's like being fluent in a language,
Yeah.
but not understanding the culture behind it.
Exactly.
You can speak the words, but not truly grasp their meaning in different contexts.
Yeah, that's a great analogy.
So how do researchers plan to address these challenges?
Well, they're exploring new ways to incorporate real-world data and experiences
Okay.
into AI training.
Uh-huh.
This could involve using, simulations or virtual environments,
Right.
or even robots that can interact with the physical world.
Okay.
The goal is to bridge the gap between abstract mathematical reasoning
Yeah.
and the complexities of the real world.
It's fascinating to think about how we can teach AI not just to think, but to understand the world around it.
It is, yeah. It's one of the most exciting frontiers in AI research right now.
Yeah.
But before we, delve too deeply into the future,
Yeah.
let's circle back to a concept we mentioned earlier. Dual view process supervised data synthesis.
Yes, please.
It sounds very technical,
It does, yeah.
but you hinted that it's a key aspect of URSA's training.
I'm curious to understand how they're training URSA to be more robust and reliable.
Right. So remember we talked about how URSA learns from its mistakes.
Right.
Well, this technique is all about making those mistakes as instructive as possible.
Okay.
And it involves two main approaches.
Okay.
The first is called error step locating,
Uh-huh.
where they actually pinpoint the exact step in the reasoning process
Okay.
where an error occurs.
It's like a detective finding the crucial piece of evidence that cracks the case.
Exactly, yeah.
Yeah.
And this allows them to provide URSA with very targeted feedback,
Okay.
helping it to understand why a particular step was wrong
Right.
and how to avoid making that same mistake again.
It's like having a tutor who can say,
Yeah.
you went wrong right here,
Yeah.
and this is how to fix it.
Exactly.
What about the second approach?
So the second approach is called misinterpretation insertion.
Okay.
And this is where they deliberately introduce subtle but significant misinterpretations of the visual information
Okay.
in a problem.
Okay.
For example, they might slightly alter the measurements in a diagram
Right.
or change the data in a chart.
It's like giving URSA a slightly altered version of reality
Yeah.
to see if it catches the inconsistency.
Well, there-
What's the purpose of that?
So by training on these deliberately flawed problems,
Okay.
they're teaching URSA to be more critical and attentive
Yes.
to the visual details.
Uh-huh.
It learns to double-check the information,
Yeah.
look for inconsistencies,
Okay.
and make sure its reasoning aligns with the visual evidence.
So it's not just about understanding the visual information.
Right.
It's about questioning it.
Yeah.
And making sure it makes sense.
Exactly.
That's a valuable skill for anyone, not just an AI.
Absolutely. It's about cultivating a healthy skepticism.
Especially when dealing with data and information.
Right.
And this dual view approach is a clever way to build that, critical thinking
Yeah.
into URSA's reasoning process.
It sounds like a very effective strategy for creating a more robust and reliable AI.
It is, yeah.
Now let's talk about another technique that's used to enhance URSA's performance. Test time scaling.
Uh-huh.
You briefly mentioned it earlier,
Yes.
but I'd love to hear more about how it works and what kind of benefits it offers.
Okay, so in a nutshell, test time scaling involves running an AI model multiple times
Okay.
on the same problem,
On the same problem.
but with slight variations in the input each time.
Okay.
Then you select the best performing solution
Right.
out of those multiple attempts.
So instead of a one-and-done test,
Yeah,
it's like giving URSA several chances to approach the problem from different angles.
exactly.
Yeah.
It's based on the idea that by exploring different, perspectives and variations.
The AI is more likely to stumble upon a robust and accurate solution.
Okay.
It's similar to how a human might try different approaches to a problem
Yeah.
until they find one that works best.
It's like brainstorming.
Yeah.
But for AI,
Exactly.
does this approach actually improve URSA's performance?
The results are pretty convincing, yeah.
Okay.
Test time scaling significantly improves URSA's accuracy
Okay.
on those benchmark data sets,
Wow.
demonstrating the power of exploring multiple solution paths.
Yeah.
It allows the AI to, consider different strategies
Uh-huh.
and refine its reasoning,
Okay.
leading to, better overall performance.
That's amazing.
Yeah.
It sounds like test time scaling could be a key technique for optimizing AI performance in complex problem-solving tasks.
Absolutely.
But now I want to step back
Yeah.
and consider the broader implications of this research.
Yeah.
We've focused a lot on the technical details of URSO, but what does it all mean for the future of AI?
That's the question that keeps many researchers, including myself, up at night.
Yeah.
What we're seeing with URSA is a glimpse into a future
Yeah.
where AI isn't just crunching numbers,
Right.
but demonstrating a deeper understanding of
Ah.
mathematical concepts
Okay.
and the ability to reason in a way that's closer to how humans think.
It's both exciting and a little unsettling, isn't it?
It is, yeah.
Where do you think this road leads?
Yeah.
Are we headed toward a future where AI surpasses human intelligence?
Well, it's important to remember that AI,
Yeah.
even advanced systems like URSA, are still tools created by humans.
Okay.
They're extensions of our own ingenuity and creativity.
Right.
And while they may excel in specific areas,
Uh-huh.
they lack the breadth and depth of human intelligence,
Yeah.
which encompasses not just logic and reasoning,
Right.
but also, emotions and intuition and the ability to learn and adapt
Yeah.
in constantly changing environment.
So it's not about AI replacing humans,
Right.
but rather about finding ways for AI and humans to work together,
Exactly.
each leveraging their unique strengths.
Exactly, yeah.
Yeah.
The real potential lies in collaboration,
Uh-huh.
not competition.
Right.
Imagine a world where AI can assist us with complex problem solving,
Yeah.
freeing up human minds to focus on creativity,
Right.
innovation,
Yeah.
and the things that make us uniquely human.
It's a hopeful and inspiring vision of the future.
It is, yeah.
But now I have to ask, what about the creative side of mathematics?
Right.
Can an AI like URSA ever go beyond solving problems
Yeah.
and actually discover new mathematical theorems or concepts?
Right.
That seems like the ultimate test of mathematical intelligence.
That is a fascinating and profound question.
Yeah.
So far, we've focused on training AI to be logical and
Right.
analytical and systematic.
Uh-huh.
But what about intuition? Those flashes of insight that often lead to breakthroughs
Yeah.
in human understanding.
Yeah.
Can we teach AI to, think outside the box
Right.
and make intuitive leaps?
It's an intriguing challenge.
It is.
Can AI ever replicate that aha moment
Yeah.
that human mathematicians experience?
It's a question that pushes the boundaries of our current understanding
Yeah.
of both AI and human cognition.
Right.
But if we could crack the code of mathematical intuition,
Yeah.
who knows what incredible discoveries await us?
It's a tantalizing thought to end on.
It is.
The potential for AI to not just solve problems, but to make genuine contributions to our understanding of mathematics
Right.
is truly mind-blowing.
It is, and that's what makes this field so captivating, right?
Yeah.
We're constantly pushing the boundaries of what we thought was possible,
Right.
both in terms of AI and our own understanding of intelligence itself.
This has been an incredible deep dive,
It has.
full of fascinating insights and thought-provoking ideas
Yeah.
about the future of AI and mathematics.
Absolutely.
But before we wrap up,
Yeah.
I'd like to leave our listener with one final question to ponder.
Okay, I'm listening.
We've explored the capabilities of URSA
Mm-hmm.
and its potential impact on various fields.
Yeah.
But what about the ethical considerations?
Yes, the ethical implications of AI.
Right.
They're crucial to consider
Mm.
as these technologies become more sophisticated
Yeah.
and integrated into our lives.
Right.
It's a discussion we need to have as a society
Yeah.
to ensure that AI is developed and used responsibly
Absolutely.
and for the benefit of all.
It's not just about what AI can do,
Right.
but about how we use it and
Yeah.
what kind of future we want to create with it.
Exactly.
But for now,
Yeah.
we've reached the end of our deep dive
Okay.
into the world of URSA and multimodal mathematics.
It's been a pleasure exploring this fascinating topic with you.
And to our listener, thank you for joining us on this journey of discovery. We hope you've gained some valuable insights and a renewed sense of wonder about the potential of AI and the beauty of mathematics.
Absolutely.
But that's all the time we have for today's deep dive. We were just talking about the ethical considerations surrounding AI as systems like URSA become increasingly sophisticated.
Right. It's crucial to address those ethical aspects proactively. Ensuring the responsible development and employment of AI.
Absolutely. It's a conversation we need to have as a society.
Yeah. And it's not just about, preventing harm, but it's about ensuring that AI is used to benefit humanity as a whole.
I completely agree. But shifting gears a bit, for our listener, if this deep dive has sparked your curiosity, we encourage you to check out the full research paper on URSA. It's full of fascinating details and insights that we couldn't cover in our conversation today.
Definitely. And if you're feeling adventurous, why not try experimenting with some of these techniques yourself? I mean, there are open source tools and data sets available that can, help you get started with multimodal AI and explore the possibilities of chain of thought reasoning.
That's a great suggestion. You never know, you might stumble upon the next big breakthrough in AI.
Exactly. Now, before we wrap up our deep dive, I want to leave our listener with a final thought.
Okay.
Something to ponder as you continue exploring this fascinating field.
I'm all ears.
We've discussed URSA's remarkable ability to, grasp and reason through mathematical concepts.
Yeah.
But what about the role of intuition in mathematics?
Okay.
Human mathematicians often rely on those flashes of insight,
Mm-hmm.
those intuitive leaps that can't always be explained by pure logic.
Right. It's that aha moment, that sudden clarity when a solution appears, even if you can't quite articulate how you got there.
Precisely, yeah. So the question is, can AI systems like URSA ever cultivate a sense of mathematical intuition? Can they learn to make those intuitive connections that often lead to breakthroughs in human understanding?
It's a fascinating question. We focused on training AI to think logically and systematically.
Yeah.
But could we also teach it to be more intuitive,
Yeah.
to see patterns and make connections that might not be immediately obvious?
It's a challenge that pushes the boundaries of our current understanding of both AI and human cognition. But if we could crack the code of mathematical intuition, it could open up entirely new realms of possibilities for AI, leading to even more profound discoveries and innovations.
It's an exciting prospect to consider. Could AI one day surprise us with a mathematical breakthrough that came from a place of intuition rather than pure logic? That would be truly groundbreaking.
It's certainly a possibility,
Yeah.
and that's what makes this field so dynamic and full of potential.
Mhm.
We're constantly pushing the limits of what we thought was achievable, both in terms of AI and our understanding of intelligence itself.
This has been an incredible deep dive, packed with insights and thought-provoking ideas. Thank you for joining us on this exploration of URSA and the future of multimodal mathematics.
It's been a pleasure sharing this journey with you. And to our listener, thank you for your curiosity and for diving deep with us today. Keep exploring, keep questioning, and keep pushing the boundaries of knowledge.
Until next time.